Hello, this is Math 2231 coming to you from the College of DuPage for summer 2020. The title of today's lecture is To Infinity and Beyond. By way of introduction, we've been talking a lot about limits because calculus is the study of limits. And so we talked about the limit as x tends to c of f of x equal L. Thus far in our study, both c and L, we're taken to be real numbers. They have fixed homes on the real number line. This changes today. Today we're going to be talking about infinity. It's important that you know that infinity is not a real number. It can be the limit of a sequence of real numbers and does live not on the real number line but in the non-incorporated fringe area of the real number line. Arithmetic is different with infinity. And although there are different orders of infinity in higher level math, there is no beyond for infinity. Sorry, Buzz Lightyear. So today we're going to be talking about the limit as x tends to either plus or minus infinity. We're relaxing the constraint on c of f of x equal L. These will be seen to be horizontal asymptotes. We will also talk about the limit as x tends to c of f of x equal plus or minus infinity. And these are going to be vertical asymptotes. So let's begin, and we're going to consider the function given by 3 over x minus 2. Well, if we approach 2 from the right, we see that as we get closer and closer to 2, this goes off to infinity. It increases without bound. You can see this with the numbers here. And as we approach 2 from the left, this goes down and down. It decreases without bound. Now that means that this limit will be called infinity coming from this side. This limit coming from this side will be called minus infinity. But the limit doesn't exist here because the left is not equal to the right. We do have an epsilon delta definition for that, and it's shown here. Now here you see that the limit from the left and the limit from the right are both infinity, so we could say that this limit actually equals infinity. Now here there's some discussion about this failing to exist, but it's equal to infinity. This is a subtle distinction and will not cause any problems. Go with the flow. And we will talk about this. And again, there's the epsilon delta definition. Again, this course is not in the main about epsilons and deltas. Okay, so let's do a problem. So you determine the limit of each function as x approaches 1, both from the left and the right. So there's these things. You know what to do. Let's see how you did. Alright, so in the one in A, the limit as x tends to 1 is going to be infinity because the limit from the left and the limit from the right both are equal to infinity. The limit's not going to exist for this one, although the limit from the right is going to be minus infinity and from the left is going to be positive infinity. And you may recall this lines up with our definition of vertical asymptote. If a function approaches infinity or negative infinity, then the line x equals c, as we're approaching that, is called a vertical asymptote. And you recall that a vertical asymptote, this is a theorem, and this can be proven with epsilon deltas. But basically, you have a vertical asymptote if the denominator equals 0 and the numerator does not equal 0. So here's a problem. You're to determine all vertical asymptotes of the graph of these functions. You have 3 to do. You know what to do. Let's see how you did. Okay, so on part A, you should have concluded that x equal minus 1 is a vertical asymptote. Here, you would have, this is part B, you would have concluded that there are 2 vertical asymptotes, x equal minus 1 and x equal plus 1. Here you see that there are an infinite number of these. Anytime the sign of x is equal to 0, you have an asymptote. So these asymptotes occur at x equal n times pi, where n is any number. That is, n could be 0, n could be plus or minus 1, n could be plus or minus 2, dot, dot, dot. By the way, the dot, dot, dot does go off to infinity. Now, that theorem that we talked about before, the numerator does have to be non-zero. 0 over 0 again is an indeterminate form, and we will see that a lot in this course. Okay, so here we are to determine all vertical asymptotes of this graph. You know what to do. Let's see how you did. In fact, we're going to see how you did in 11.1.